Perfect.
Problem, we want to simplify everything inside the parentheses first. So, I want to figure out the exponents. You have 1 over x plus 1 over 2x. So you got to add them. Divided by x to the 1 over 4x, all to the x over 5. So simplify the exponent on the top. 2 1 over 2x over x to the 1 over 4x. So that gives you x to the 3 over 2x. And then you can bring the denominator up to the top, and you're just going to subtract the exponent from the numerator's exponent. So you have minus 1 over 4x. So you just multiply the first term by 2 over 2. So you get 6 over 4x minus 1 over 4x. That just gives you x to the 5 over 4x. And then you distribute the exponent outside the parentheses by multiplying. This times x over 5. And that just gives you x to the 1/4. This problem looks pretty big, but it's not too bad. What you can do is factor out negatives in the denominators and the exponents, and then bring the terms up to the top. So start with doing that. So you have x to the c plus 1, and you have minus 2c minus 1, and then y to the c minus 1 minus 2c plus 1. Because I just pulled negative signs out of here and here. And then inside the parentheses you have x to the 2 times c plus 1 would be minus 2 times c minus 1. And then y to the 2 minus 2c. And then you just have plus 2c. And that's to the c over 4. C, y to the minus c. And inside the parentheses you got x to the 2c plus 2 minus 2c plus 2 times y to the 2 minus, I can just leave the c terms out. And that's all to c over 4. So you get x to the minus c, y to the minus c times x to the 4th y squared to the c over 4. And then you can just distribute the exponent, and you're left with x times y to the 1/2. Well, actually, I should show it. So you get x to the 4 times c over 4 times y squared times c over 4. This gives you x to the minus c, y to the minus c, x to the c, and y to the c over 2. So that gives you x to the c minus c times y to the c over 2 minus c equals x to the 0. You have y to the 3c over 2, which just gives you y to the 3c over 2. Okay, I'm going to move on to simplifying radicals. For this problem, You just want to look at factors of 135. So the obvious one is to use 5 as a factor, so that you have 27 times 5 under the cube root. So that equals cube root of 27 times the cube root of 5. So the cube root of 27 is 3, so you're just left with 3 times the cube root of 5. Alright, we're going to use a cube root again. So 32 is actually 2 to the 5th power. So we're at 2 to the 5th times x cubed, y to the 7th, z to the 9th. And you can split up the 2 to the 5th, you can write it as 2 cubed times 2 squared. Because you just add the exponents to make it 2 to the 5th. So you have x cubed, y to the 7th, z to the 9th. And we can pull the 2 cubed out, so just have a 2. You can pull the x cubed out, and you can pull out a y squared and a z cubed. And under the radical, you're just left with 2 squared, which is 4. And there's a leftover y. And that's it. For this problem, we could just combine everything under the radicals. Just multiply them straight through. So you have 2 times 5 is 10. You have x to the 8th, y to the 4th. And because you have 8, the square root of x to the 8th is x squared. It's not. Dude, I'm dying today. So we can pull the x to the 8th out. That's just x to the 4th when you take the square root. And then y to the 4th would be y squared times the square root of 10. And you can do that because a square root is the same as saying to the 1/2 power. So if the square root of x to the 4th, that's the same as x to the 4th to the 1/2. So you just have x to the 4 times 1/2, which is x squared. Alright, here's an easier problem. When you have a radical in the denominator, it's considered an irrational term. So you have to multiply the top and bottom by the radical term. So you just have x over the square root of 5 times root 5 over root 5, because this term here just equals 1, so we're not doing anything too crazy. So you have x times root 5, and root 5 times root 5 is just 5. Okay, for this problem you have to get rid of the radical on the bottom, because otherwise the term is considered irrational. So to do that, you just multiply the top and bottom by the radical term. So you have x over root 5 times root 5 over root 5. And you can do this because root 5 over root 5 is the same as multiplying it by 1. So when you do that, you get x times root 5, and root 5 times itself is just 5. This problem's a little bit trickier because you have a cube root in the denominator. So you actually have to multiply by the cube root of x squared over x squared. And you'll see in a second why. So that gives you cube root of x squared divided by the cube root of x cubed, which is just cube root of x squared divided by x, because the cube root of x cubed is just x. With this problem, you again just multiply by root 5 over root 5 to get rid of the irrational denominator. So you have square root of 2x over the square root of 5. It's okay to split those up, times root 5 over root 5. So at the top, just distribute, and you get the square root of 10x divided by 5. And you can't simplify those because the 10's in the radical, so you couldn't divide 10 by 5 to get 2. And just a side note, when you have root 5 times root 5, you can look at that as 5 to the 1/2 power times 5 to the 1/2 power, and then you just add those together, the exponent, and that just gives you 5 to the 1, which equals 5. Alright, last problem, and we're going to use the same trick that we used in problem 7 for the denominator. So we're going to multiply by cube root of y squared over the cube root of y squared. So you have cube root of x squared over cube root of y times the cube root of y squared over the cube root of y squared. And that'll just give us the cube root of x squared y squared divided by y. And another way to look at this is to use the exponents instead of the radicals. So you could write this answer cube root of x squared y squared over y as x to the 2/3 times y to the 2/3, and then we can just bring the y up, call it y to the -1. So you have x to the 2/3, and 2/3 minus 1 is just minus 1/3. So you have y to the -1/3. And we'll just rewrite it so you can see. And when you rewrite it as radicals, you have the cube root of x squared over the cube root of y. And that's the original problem.